So here is another question on graphical analysis of one-dimensional motion. So it is given that a body starts from rest and accelerates uniformly for 30 seconds to a speed of 72 km per hour. It then moves with a uniform velocity and is brought to rest in 50 meters with a constant retardation or deceleration. If the total distance traveled is 950 meters, find the values of acceleration, retardation and the total time taken. And we have to draw the velocity time graph of the body. Okay. So first let us try to draw an approximate graph, and then we will draw the the accurate one in terms of the numerical data, numbers. So velocity time graph. So this is time and this is, let's say, velocity. This is the origin, start. So it is said that a body starts from rest, which means at t equals to 0, its velocity is 0, and accelerates uniformly. It means constant slope for t equals to 30 seconds. So let's say here is 30-second point. So it accelerates uniformly and it attains a velocity or speed of 72 km per hour. So 72 kilometers per hour is 1000 by 3600, that is 60 minutes 60 seconds. So it is coming around 20 meters per second. So it attains a final velocity of 20 meters per second. Okay, this is 30 seconds, this is 20 meters per second. This is the point, like this. Okay, this. So it attains a velocity of 20 meter per second in 30 seconds. Then it moves with a uniform velocity, that is constant velocity, and is brought to rest in 50 meters with a constant retardation. So it keeps on moving with a uniform velocity and then it is brought to rest with a constant retardation, this. Okay, so these are the important points. Okay, so let us mark these points. Okay, let this point be A, B, then C, then let's say this point is D, and let be E. You can name it anyway. Okay, so this first phase, it is 30 seconds. Okay, it is 30 seconds, the 30-second phase, okay, which is T1, this first phase. T1 equals to 30 seconds. Then DE, the constant velocity phase, let that be T2. And this is T3, the retardation phase. So let the different distance covered in these three different time phases be S1, S2, S3. Okay, the area under the velocity time graph in these three specific regions, they signify or they denote the distance or displacement covered during these time intervals, that is S1 in time t1, S2 in time t2 and S3 in time t3, because we know the area under the velocity time graph is the distance covered by the body. Now it is given that the body is retarded within 50 meters. So it means S3 is equal to 50 meter. This is given. Then it is given that the total distance covered, that is S1 plus S2 plus S3, that is equal to how much? 950 meters. So S1 plus S2 will be ST minus S3, that is 950 minus 50, which is equal to 900 meters. Okay, this is all right. Now focus on the triangle OAD. Okay, the area of the triangle OAD, that will be equal to 1/2 base into height, that is OD into AD, which is nothing but 1/2 into T1 into AD, which is the velocity, that is 20 meter per second velocity, which is equal to 1/2 into T1, which is 30 seconds, into velocity, which is 20 meters per second. So that is equal to 300 meter. And this area under the triangle OAD, it is the distance S1 covered in the time period T1. Okay, T1, which is equal to 30 seconds. So S1 we have got, S1 is equal to 300 meters. Next, now focus on, I'm using a different color ink here. Okay, now focus on this rectangle ABDE. Okay, ABDE, area of rectangle ABDE, that is equal to how much? AB into DE. Okay, sorry, AD into DE. Okay, AD into DE, and that will be equal to the distance covered S2 in time T2. But we know here that S1 plus S2 is equal to 900 meters. Okay, S1 we have already got, so S2 is equal to 900 minus S1. S1, which we have already previously calculated, 300 meters. So that is equal to 900 minus 300, which is equal to 600 meters. Okay, S2 is equal to 600 meters. Here, this 600 meters is the area of this rectangle AD into DE. AD is 20 meters per second. AD is 20 meters per second. This DE is equal to T2. Okay, DE is equal to T2. So it is 20 into T2, that is equal to 600. That implies T2 will be equal to 600 by 20, which is equal to 30 seconds. So T2 we have got, that is equal to 30 seconds. Okay, S2 we have got 600 meters. S1 we have got 300 meters. Okay, then now focus on this triangle BEC. Okay, the S3 portion, the triangle, let me use a different ink again, triangle BEC. The area of the triangle BC, is simply 1/2 into base CE into BE. Now here BE is equal to 20 meter per second. Again, BE is equal to 20 meters per second. Okay, and CE is equal to T3. CE is equal to T3. So that is equal to 1/2 into T3 into 20. Now we have already been given that this retardation happens in 50 meters. Okay, within 50 meters it is retarded. So S3 is equal to 50 meters. We have already here, it has been given from the question. S3 is equal to 50 meters. So we can put this value here. Okay, 50 meters, which is equal to S3. The area of the triangle BEC is nothing but S3, the displacement or distance covered in the straight line during the time period T3. We have to calculate T3 here. So T3 will be equal to 50 into 2 by 20. Okay, so that will be equal to 5 seconds. T3 is equal to 5 seconds. Okay, this. Now we have to calculate the acceleration. Let this angle be alpha and let this angle be beta. The acceleration of this OA portion, that is equal to AD by OD. Tan alpha is equal to AD by OD. Acceleration, slope of OA curve, tan alpha is equal to AD by OD, that is equal to AD is 20, T1 is 30 seconds, 20 meter per and 30 seconds. That is equal to 2 by 3 meters per second square. Okay, that is the acceleration. Then we have to determine the retardation or deceleration. So tan beta, deceleration or retardation, tan beta, it will be negative because it is retardation or deceleration, negative of BE by EC, BE by EC minus BE by EC or C, whatever it is. So it is minus 20, which is BE, BE is 20 and EC is T3, which is equal to 5 seconds. We have calculated here T3. Okay, EC is nothing but T3, so it is 5 seconds. Okay, so that is equal to minus 4 meters per second square. This is the retardation. Now the total time taken, is T1 plus T2 plus T3. Okay, T1 is given, T1 is 30 seconds, T2 we have calculated 30 seconds, T3 is 5 seconds. So 30 plus 30 plus 5, which is equal to 65 seconds. Okay, this, then it was asked to find the acceleration, retardation and total time taken. So we have done all that. First we determine the acceleration, then the retardation and then the total time taken. Okay, and also we draw the velocity time graph for the object. Okay, this is the thing.